Our project was based on the classification of movie posters into multiple genres. The purpose of our project was to allow users to input movie posters, and then it would predict or take the input of what the poster is and guess the genre of the movie. Our motivation behind this project was that many movies are coming out each day worldwide. It is often that the movie poster is more readily available to the movie trailer that isn't released until closer to the movie comes out. And we wanted to help people find movies based on their preference of genre, and we thought this would help. The methods we went through in creating our project was first data collection, data preprocessing, model selection, model training, model evaluation, model tuning, and deployment. We found a good data set off of the website Kaggle. Our data set collection was roughly around 7,000 movies, and they were predefined into 25 movie genres.
The first thing that we need to do is to prepare our data. So we will create a new chain set based on the original chain.csv file that we have and keep the original file for validation later. We will check for any missing data to see if we need to fill up anything. And lucky for us, we do not have any missing data in this data set. We also need to remove some duplicates based on the ID. So I do this method based on remove duplicates method in Python. When we balance the data, we want to remove the minority classes, which include reality TV, no information, news, shorts, and Western category. We also decrease the size of majority classes, such as drama, comedy, and action, since we do not have enough time to build the functions to remove it. We just remove it manually in our CSV file. When we select our model, we want to make sure that we understand what the data set is about, and this data set is multi-label classification. So based on what we have in here on the data set, where they already have the binary classification for each of the category, we will use KNN and CNN approach.
The first of the two models we did, we imported TensorFlow, TensorFlow Keras, Pandas in order to import the dataset into our code, utils, and NumPy. We set the width and height of the image to 400 and 430 respectively, and we created a loop to add the image to a NumPy array. We dropped the ID and genre column to have a binary set of just the genres. Along with all of that, we used batch normalization to normalize the data. We split the data between testing and training data using 85% of it to be training data and 15% of it as the testing data. And we did all of this to help create the CNN model.
Go to the second model that we have, which is the K nearest neighbor. The first thing that we're gonna do, as previous model did, is to import some necessary packages: TensorFlow, Keras preprocessing, utils, NumPy, Pandas, the chain test split model, and especially we need to add the model K-neighbor classifier from the sklearn. And in this model, I set the width and the height a little bit different to 350 for both. Still put the images into the array using the for loop. And because for this model, we need to have the 2D shape for both the X and the Y. So we need to reshape the 3D images to 2D by setting the reshape function. And the first number will be the length of the array X, and the second one will be the 3D layer times the width and the height of each images. Next one, we will actually generate a KNN model. I choose the number of neighbor of 5 because we have a total of 20 categories after classification, and we choose the number of neighbors based on the square root of those total, which is around 4.4, and I round it to 5. And after that, we set the model to K-neighbor classifier and fit the model to X-chain and Y-chain data. We set the Y-predict to the model and predict it to the X-test. Then we generate a prediction and accuracy to see what it looks like. And so far we got 88% of accuracy with a classification error of 12%.
For the testing of our movie posters, we decided to start with one genre for the actual, then we increased it to 2 and 3 to test the multi-label classification on the different movie posters.
So for the first poster, we have a poster that was tagged as a drama movie. CNN results show drama, and KNN results also show drama as a top choice, and it's working correctly. Poster number 2, we actually see an outperform in KNN when it can categorize horror correctly as a first choice, while for CNN, it put drama, adventure, and action as their top choice, and none of them match the actual category, which is horror. For the third poster, we have 2 actual categories, which are drama and music. CNN predict drama correctly, while KNN cannot predict any of the genre right. So we are actually seeing a slighter better performance for CNN model in this case.
So for poster 4, we got about the same kind of accuracy for both models. They both only predicted one correct. For the CNN model, it predicted adventure correctly, and for the KNN model, it predicted action correctly. For this poster, the CNN model predicted horror correctly, where it should be horror, mystery, and sci-fi. The KNN model did not predict any of them to be correct. And for poster 6, the correct ones were animation, adventure, and comedy. And the KNN model predicted comedy correctly, and the CNN model predicted 2 of them correctly, being adventure and comedy.
So for validation and testing, we chose a varying of accuracies. We binary, categorical, sparse categorical, top K categorical, and sparse top K categorical. Of all of these, binary worked the best, which is used to measure the percentage of correctly predicted binary outcomes. For the CNN model, it reached between 85 to 93%, and for the KNN model, we reached 87%. So this is the discussion. We had shortcomings and limitation. For us, our biggest was time. Just getting through everything that we wanted to get through was a real struggle, but we buckled down and worked hard and got where we needed to be. Another thing that we struggled with was reaching the accuracy goal. We really wanted to reach between 85 to 90%, and starting out we were really getting low numbers, around 40 to 50%. Another problem we came across was choosing the right technique for the highest accuracy, and that ended up being more towards the CNN model than the KNN model. So what would be next for us? Probably to create a GUI where the input would be the movie poster and it would spit out the genre. And to go even further, we could possibly upload a version to the internet, which would be free for everyone to access. And even thinking about possibly putting in like a preference portion where they could input the poster and it would show whether or not the movie they put in was of their user preferences. So just to sum everything up, looking at the CNN versus the Canon model, we really discovered that the Canon model is most powerful in predicting single labeled genres, whereas the CNN is better at predicting multi-label genres. Some further development would be testing more CNN layers and trying to implement other models for better accuracy. So for our project management, we really wanted to look at each other's strengths and weaknesses. And based on this, we all decided that Emma and An would take a leadership role over the development aspects, and myself and Morgan would take leadership roles over the research and presentation. And even though we decided to take leadership roles on these specific aspects, everyone was a part of the group, every person's like topic. So for An, she really specified with the Canon model, the GitHub, finding the dataset, and also adding to the paper. For Emma, she did the CNN model, the proposal presentation she played a big role at, and as well as the final presentation in the report. Myself did a lot of research for like related works and finding out what worked for them and what didn't, and also the final presentation and the report. And for Morgan, other Morgan, she helped with researching CNN and Canon models, as well as putting in efforts towards the report and the final presentation. These are just the references that we had, and then this is the appendix with links connected to the GitHub, the data set that we used, and some of the original source code.